An AFM is an atomic force microscope. It lets you see things that are very, very small, all the way down to the nanoscale. How does an AFM work? An AFM uses a cantilever with a very sharp tip to scan over a sample surface. As the tip approaches the surface, the close-range attractive forces between the surface and the tip cause the cantilever to bend towards the surface. However, as the cantilever is brought even closer to the surface, increasingly repulsive forces cause the cantilever to bend away from the surface. An AFM has a Z scanner that moves the cantilever up and down, an XY scanner that moves the sample back and forth underneath the cantilever, and a position detector that records the bending of the cantilever. The position sensor works by tracking a laser beam that is reflected off the flat top of the cantilever. Any bending in the cantilever will cause changes in the direction of the reflected beam. The position detector then tracks and records those beam changes. Using the detection method explained earlier, an AFM images the topography of a sample surface by scanning the cantilever over a region of interest. The raised and lowered features on the sample surface influence the bending of the cantilever measured by the position detector. AFM generates an accurate topographic map of the surface by using a feedback loop to control the height of the tip above the surface. There are two major methods of AFM imaging: contact AFM and non-contact AFM. In contact AFM, the cantilever scans across a sample with its tip touching the sample surface. Because the tip is in contact with the surface, strong repulsive forces cause the cantilever to bend as it passes over the surface features. The advantage of this method is the relative simplicity of its technology. However, there are disadvantages. One disadvantage is that the sample can be damaged by the gouging action of the sharp tip. Another disadvantage is that while the tip is gouging away at the surface, it also grinds down the tip, which reduces the quality of your image. In non-contact AFM, the cantilever oscillates just above the surface while it scans, but the tip does not touch the surface. A precise, high-speed feedback loop is used to keep the cantilever tip from crashing into the surface, thus retaining tip sharpness and leaving the surface untouched. As the tip approaches the surface, interactions between the tip and the surface cause the oscillation amplitude of the cantilever to decrease. The feedback loop corrects for these amplitude deviations and constructs an image of the surface topography. Non-contact AFM has many advantages over contact AFM. It preserves your sample surface because the tip and surface are not touching. By prolonging the sharpness and lifetime of the tip, it allows for high-quality imaging over many scans. This also brings down the total operating cost of the instrument, as tips are expensive to replace. Atomic Force Microscope, or AFM, is a powerful tool that enables you to see, explore, and obtain measurement data from your samples at the nanoscale. For more information, please visit ParkAFM.com.